Okay, this video is going to help us, or help you, to do assignment number 2. Okay, first thing, what we need to do is we need to open up Visual Studio. We're going to import our queues functions from assignment number 1. So let's go into create new project, console, next. We'll say assignment number 2, or assign 2, how's that, on the desktop. And what we need to do is we need to copy our queues functions over to this folder. Okay, and we'll even copy the main from there. So we don't need this because we're starting with the base. Our basis is assignment 1. Okay, so what we're going to do is we're going to go in here. I have the assignment, the files already here, so I'm going to take them and paste them into here, and we'll import them. So we'll import the header, add an existing item, because we're going to add to these files. So queues.h, we're going to add functionality, recursive functionality to these functions, to these files, and main as well. So we'll start from there. Okay, so we have so queues.h. What we want to do, we want to add certain functions that are recursive to it. Okay, so these are all the queue functions, and what I need to be able to do is I want to add some recursive queue functions. Okay, so I'm going to go in here and I'm going to add recursive queue functions, and these are all from the slides. Okay, so we had what we're going to need. We need some way to get the head of the linked list. For it's always going to be the case. We're always going to need this. So link return head of the linked list. Okay, so we need that. We need to be able to get that in order to do some of the things we need here. Okay, because a lot of these take as input the head of the linked list, and you need a getter for that because it's a private variable. Okay, so we have we need that. So we have the different functions were count. We're going to implement all of them in case we need them. So link x. Okay, we have these implementations. Link, and then we have delete r. Okay, it takes a link for the parent, and then a link for the child. Right, which you can get from the head, and then what the head points to, and then an item that we're looking for, v, and that's it. Okay, then we have the visit function. So void, we have visit, link h. This is all straight from the code that we got. Void traverse, and then this took a link h. We took a void, and then as a function pointer, it took visit. So here we're expecting a function pointer, and here we have a link. I think I had h before, but I'm going to use the same. So it's expecting a link as an input, and then traverse r looks exactly the same, basically exactly the same. So I'll just have a second definition here. Just call it traverse r. Okay, so those are the functions. Control S to save. And now I'm going to take these guys and I'm going to implement them. So Control C and go over. So I save this one and go to queues.cpp, and here at the bottom, so these are our queues functions, and here is our recursive. So I could just put in here, I could put assignment number 2, right? I could say 2. These are the recursive functions, recursive traverse functions, I guess you can call them. Okay, we'll put them here. We have to take out they're not statements. We're going to define them, right? And you can put. I'm not going to spend a lot of time putting the comments, but you should put the comments that define how these things work. Okay, they're recursive, traversal. Okay, so you probably want to separate them a little bit. Okay, so again, the code that you're going to get here is exactly the same as what you've seen. The return head might be a little I haven't shown you, but it's just return the head of the linked list, right? So the return head basically just return, right, p head. Why you can't get it directly is because it's static. It's limited to this file. So only these functions can return it, and this function is the only one that can return the head. Okay, that's fine, no problem. Count, again, this is all coming from the notes. X is null, then return 0, okay, and then return 1 plus count X, all right, P next. Okay, if you forget how any of these functions how they work and you want an explanation, go to the slides and where these functions are defined, and you'll get a nice explanation for what's happening in each of these. Okay, I won't explain them all over here. I want to just make this video a little bit shorter. Okay, so delete R if child is null, right? Then return, right? Return null, right? The child is the one that comes after the parent, right? And then here we're going to, so this is the termination. You can comment it. It would be nice if you do. You should actually. If child, right, dot data dot SID, and we know that exists because that's how we define it, is equal to v.sid, what we passed, the SID that we passed in the item. Then we're going to go through the steps, right? We're going to, wherever the parents, p next, is going to be equal to the child's p next, right? We're gonna basically delete the child, right? Free the child. Okay, and then we're gonna delete. We're gonna call delete R to go to the next one, right? So we start at the parent. We're basically continuing to search through parents, p next, right? That's the child, right? And then on v. Okay. All right. So that's if they're the same, right? And then else, otherwise. You just if it's not equal to what you're looking for, then go to the next node, right? So call delete R on the child and the child's child, right? And you're still looking for V, right? That's it. Right, and then Control S to save. So this is the delete function, and we can implement. Let's see, we can implement the visit function. Okay, so the visit function, we're just going to make it really simple. It's just a printf. Okay, and then what we're going to do is we're going to print the SID, right? So \n, then SID of node, and then we'll just give the number here. And then go here. We could \n if you like. It's a good idea. And then it's basically what we're looking for is, so the link, right? Link is we got to look at the data. That's what we want, and the SID. Okay, that's the variable that we're looking for, that we want to print. Okay, and then Control S. Now printf is not here because probably what I'm missing at the top is standard IO right here. So include, right, standard IO dot h. Control S to save, and now the printf should be fine. Good. Okay, so that is our visit function. Okay, so now we're going to do the traverse and traverse R. Both of these come from straight from the notes. Okay, and I sort of explained it. So if h equals null, okay, then return. We reached the end of the list, right? We got to the end of the linked list. Otherwise, here is where we visit. We print first, and then we go to the next node. So we're doing it in the forward direction. So here we're gonna dereference visit, right? Because visit is a function pointer. Okay. This means dereference it and then call it at h. Okay. So we're going to visit, and then we'll call traverse to go to the next node. I have traverse. Traverse h, but we're calling it for the next node. We're going to the next node, and that's using pnext, right? What pnext points to, and then we pass the function pointer so that it can be called again. Okay, now you can do the same thing here. What I'm going to do, I'm just going to take this guy, copy, paste, and then just all I got to do here is change the order, right? Control X, like this, and this will print it. If you go to the next one before you print, then when recursion unfolds, you're going to print after, which means it's going to print backwards. Okay, so these are the functions. So hopefully everything's good there. I don't see any errors in here or here. Now we got to use these functions. So let's go to main. So in main, what do we have? We have, let's see, we have our initialize our queue, create and add nodes, and we did this already. That's good. I could do it that way. Or this, I showed that there was different ways to do this. And now what I can do is here I'm dequeuing. I don't want to do any dequeuing here. Let me see. Do I want to dequeue? I'll empty the queue at the very end. I'll empty it at the end. Okay. So what do I want to do first? What can I test? I can do a test on the count function, right? Right, I can test count. So I can go printf and go here, \n. We'll say the number of nodes in the queue is, and then %d, right? And then \n, let's say, and then we'll do count. And what we need the head, right? So we'll call the return head function. And we're good. Control S. We can test this one out first. So we'll test this guy and see what happens. If there's any errors, we'll fix them. If not, good. All right, let's see if it prints it out. Okay, this does the SIDs. Oh, yes, this is when it dequeues, it prints it off. Okay, that's fine. There's 10 nodes in the queue. Yeah, 0 to 9. Good. That's great. So the count function works. We could actually take count at the end and make sure that they dequeued properly, right? We could do this. That will check to see that they dequeued at the end. Okay, 0. So good. So it did work. All right, let's close that. Should always, at the end of the queue, I did go there. I should do double. Okay, so just to make it look nicer. All right, next what we want to do is test. We can test delete and all that stuff if we like. So we can go test delete r, right? We can do that. So item v, right? And then we can say v.sid equals pick a number. Say 13. And then what we're going to do, we're going to delete. Do we have a 13? No, we don't. We don't have 13. We have up to 10. Let's go with 7. How's that? All right. Delete R. And then what we want to do is, okay, so delete R takes a link to the head, so we need to return. That's why we need that function, right? Return the head. Then it needs a link to, okay, a link to the child. So delete, okay, so we need the pnext of return head. So we could call it again if we want. Return head, and then that's the head, and then we need its pnext. Oops, pnext. Okay, I should have pushed enter. And then what are we looking for? We're looking for v. We're looking for an item with the value with v, right? Okay, so that'll do the delete. Control S. Now we've deleted it, so now let's take a look at the queue, right? So we've got the delete. Control S. Let's run it and see if 7 is missing from when we empty the queue. 2, 3, 4, 5, 6. 7 is missing. 8. is there, and now it goes to 0. Yeah, because we count the number of queues first, right? If we had done a count, we could run another count after the delete. We could run here. We could run another count after the delete if we wanted to, right? Number of nodes in the queue after the delete are okay. Operation, let's say, is okay. This is number of nodes in the queue after dequeuing all nodes should be 0. Okay, and then, okay, that's fine. We should have one less after we delete. Let's just check it. Yeah, after, so there's 9 after the delete, and then we print them all off. Okay, that's good. And then what's next? Before we delete, before we do the delete, let's do a traverse in the forward and reverse direction. So we could say printf, and we could say like this. We could say \n. Traversing list in forward direction gives, and then what do we want to do? Well, it's recursively, so then we'll just do \n. Alright, let's go ... \n, go like this, and then just call traverse, because it's going to print, right? And then return head, because it needs that, and then it needs the visit function. And the exact same thing, instead of forward direction, we can do it in the reverse direction. Control C, right? And this will be in the reverse direction. Direction is, now what I should do, I should put another space here, and another space on this guy. A lot of times people like to put, I don't know if you've ever seen this, printf, we go like this, we go \n, and then we go like this. Something like that, and then \n. Okay, and this is just like a line underneath the header. You can do that if you like. Okay, Control S. When I do this delete operation, I should also do \n here twice, just to give some extra space. We don't need that many spaces. Okay, so we've tested all our functions. Let's just run everything and see, make sure everything works. All right, we have, I put too many spaces here. Well, in the forward direction, I could edit that function, and so they're not on a separate line. Let me just do that so that it looks a little nicer. Go to queues.cpp. Let's see. It's my visit function. My visit function has too many spaces. So let me take this guy out. Control S. Okay. That's print. Okay, that's a little bit nicer. Yeah. Okay. So number at the beginning is 10. We traverse in the forward direction. So that's 0 to 9. The reverse direction, we got something wrong here. 0 to 9 again. I probably called the traverse instead of the traverse function there. That's probably what I did, because I copy and pasted. So I forgot to call V. This is the reverse direction. This should be traverse R. Control S to save. Now everything should be good. Let's do a test. Yep, okay, so 10, 0 to 9. Aha. 1, 2, 3. Oh, something's wrong with the reverse traverse. Let's see what's going on here. Let's see. Something is wrong. We have something wrong in the way it's printing. Okay, that's fine. We'll do that. We'll look at that. So the delete operation worked fine, and everything else at the end. So it's the reverse traverse that is giving us a problem we have to debug. Okay, so traverse R. Let's go look at our traverse R. Here we traverse. We go to the next one. We visit. Yeah, we've reversed everything. Something could be wrong in our. Okay, let's look at the main. Here we call. So forward direction gives traverse. Should be right. Probably, let's see what happens if probably the head is being moved. Probably the head is being moved. When we traverse. Let me try to take this guy out. Okay. Take this guy out. Take this guy out. I just want to test the theory that the head might be moved from this. I wonder if that's the issue. Let's just run it and see. We can always very quick test. Okay, so we're gonna go reverse. Nope, same difference. Okay, so that's not the problem. Has nothing to do. Let me see if I can remove the count function and see if that does something to it. I just want to see if something's happening to head. It shouldn't, but yeah. Reversing the list in the reverse direction. Okay, so that's not the issue. That's not the issue. The issue is somewhere in the traverse code, and we'll find it. And, well, when you copy, let's see here. Traverse calls itself, traverse R calls, traverse. Okay, there we go. That's the issue. Alright, maybe some of you saw it when I was going through and you're probably screaming at the video. Sorry about that, guys. Okay, so that's the issue because I copy and pasted, but I didn't change the self call. Okay, because it's recursive. Okay, so this all works, should work. So let's see what happens. Let's run it, make sure everything works. Okay, so 0 to 9, 9 to 0. Delete the 7th, yes, and empty the queue. Good. Everything all works beautifully. Alright, I hope that helped with assignment number 2. It's not that difficult, so just thought I'd walk you through the steps. Alright, take care. Have a good day. I hope you enjoyed the video.